Bismillahirrahmanirrahim. In this lecture, we are going to speak about the Newton-Raphson method, or simply known as Newton's method. Let's define what do we mean by Newton-Raphson method. The Newton method is just a way to quickly find a good approximation for the root of real valued function. It's just a way, or sometimes known as an iteration. So Newton method is just a method to find a good approximation for the root of a real valued function. A real valued function. F of x equal to 0. So it's just an iteration to find root or the solution for the function or f of x equal to 0. The idea of the Newton method is dependent on the tangent line for the graph of the given function. So with that, we have this function which is differentiable. Let's assume that we have this function, and the graph of this function is given by f of x. Or let me just, I don't need to be, so the 0, 0. So that this is the graph of f of x. This point is the 0 of the function. But in general, we don't know what is the exact solution for some function. And we need to find that 0 or the root of the function f of x equal to 0. So we'll start from some point. So with that, we start with xn. Now at xn, we will find the tangent line. We say the tangent line to the graph of f of x is given by y equal to f prime at xn multiplied by x minus xn plus f of xn. So if the tangent line at this point be something like this one. Now the tangent line is crossing the x-axis at some point, at this point. Let me call it xn plus 1. Later on, we'll use it. Now to find the form of the Newton method, we say let y equal to 0. At the intersecting point of the tangent line, y equal to 0. So I will let the equation or replace y by 0 and solve for xn or x. This will give me f prime of at xn multiplied by x minus xn plus f of xn equal to 0. Or it is f prime multiplied by x minus xn equal to minus f of xn divided by the derivative x minus xn equal to minus f at xn divided by the derivative. So x is equal to xn minus f xn divided by the derivative. And this is the iteration on by the Newton method. So we are looking for 0 for a function f of x starting at some given value. We call it the initial value, x sub 0, or the initial guess for the function. The initial guess will be used for the root, and we will find the best approximation or the closest root for that starting guess. It's worth to mention that also for some function, or the Newton method will give you the closest root to the initial value. For example, if we have more than one root for the function, so the one that we will find by the Newton method will be the closest one to the initial guess, to the starting point or the starting value. For example, let's use Newton method. Or Newton-Raphson method. To find a root of f of x equal to x to the power 3 plus 3x minus 8 with initial guess x sub 0 equal to 1. And the difference between two executive iterations is less than 10 to the power minus 4. We'll come to this part later on. So I have x sub 0 equal to 1. We have f of x equal to x to the power 3 plus 3x minus 8. So we need to find the derivative f prime of x equal to 3 x squared plus 3. You have x0 equal to 1. The form or the Newton method give me x n plus 1 equal to x n minus the function at x n divided by the derivative. So if x is x sub 0 equal to 1, x1 is equal to x sub 0 minus f at x sub 0 divided by the derivative, which is equal to 1 minus. Replace or substitute 1 in the given function. I will have 1 to the power 3. Now we are using this function. Find the value of the function at x equal to 1. Plus 3 multiplied by 1 minus 8. Divided by the derivative, which is the 3x squared plus 3. That will be 3 multiplied by 1 to the power 2 plus 3. This is equal to 1 minus we'll have minus 4 over 6. That is 1 minus minus 4 over 6, which is equal to 10 over 6 and that will give me 1.6666, and I need one more. So this is x1. x2 is equal to x1 minus f of x1 divided by the derivative. That will be 1.66667 minus f of 1.6667 divided by the derivative at this point. 1.666 minus 4. Okay, this is will be 67. So evaluate the function at the given point, the new one, which is 1.6667, and divided by the derivative at that value. And I will have, if you just use the calculator for this one, we get x2 is 1.52287. I have that. This is the first one. This is the second one. This is the second iteration. Let's move for one more. X2 is 3. That will be x2 minus f of x2 divided by the derivative x2, which is 1.52287 minus the function at this point, 1.52287 divided by the derivative 1.52287, and this will give me 1.5 12792. Say 79. 5 digits. Now if we compare between x2 and x3, x2 and x3. Now I got the first digit after the decimal point is repeated. So this is up to 10 to the power minus 1. So the first digit after the decimal point are matching now. So let's move for one more step. Let's find x4. That will be x3 minus f of x3 divided by the derivative of x3, which is equal to 1.51279 minus, now if the value of the function at this point, which is 1.51279 divided by the derivative at that point, 1.51279. This will give me 1.51274. 1.51274. If we see the digits, okay, I have this is x3 and this is x4. The first one, 5, is repeated. Second one is repeated. 2 is repeated. 7 is repeated. So this is accurate up to 10 to the power minus 4. This is the meaning that given in the question. If we go back to the problem, with this condition, xn plus 1 minus xn is less than 10 to the power minus 4. It means that if we got the 4 digits matching after the decimal point, then we should stop. So the root for this one, then stop at this point, which means the root 4. The function f of x equal to x to the power 3 plus 3x minus 8 is given by x4, which is equal to 1.5127. We can say the approximated one. Now for the function f of x equal to x to the power 3 plus 3x minus 8, since it is a function of power 3, it means that we should have 3 roots. We should have 3 zeros. If we have 3 real zeros, the Newton method only will give me one of them, not all of them, depend on my start point. If I want to get the other zeros, I should start or use different value for the initial guess. We use x sub 0 equal to 1. If I use x sub 0 equal to a different value, I will maybe approach the second zero of the function. So this is the idea of the Newton method. It's just to find the good approximation for one of the roots of the function f of x equal to 0. Let's have another example. Let's use Newton's method or Newton-Raphson method. To find the positive solution of equation 2 sine x equal to x. So use x sub 0 equal to 2. I need to find the 0 for this one, or positive solution. So the function will be, I want to use x minus 2 sine x. This will be the function that I'm going to use to apply it for the Newton's method. The derivative is 1 minus 2 cosine x. And the iterations will be x sub n plus 1 equal to x minus f x divided by the derivative xn and xn there. That will be xn minus xn minus 2 sine This is my function divided by the derivative, which is 1 minus 2 cosine xn. On start, we have x sub 0 equal to 2. x1 will be 2 minus, replace xn by 2 will be 2 minus 2 of sine of, or 2 times sine, divided by 1 minus cosine of 2. This will give me 1.90040,100. x2 will be 1, using the now the new value for x, using this one, 1.90100 minus 1.90100 minus 2 sine of 1.90100 divided by 1 minus cosine. Sorry, this should be 2. There is 2 missing. Cosine 1.90100, which is equal to 1.89552. So this is the second iteration. Third one, x sub 3 will be 1.89552 minus 1.89552 minus 2 multiplied by sine of 1.89552 divided by 1 minus 2 cosine of 1.89552, and this will give me 1.89550. So this is the third iteration. And you can see, if we compare between x2 and x3, after the decimal point, I have 8, 9, 5, 5. So it's accurate up to 4 decimal points, which is enough, even if it is not given in the question. But if it is given in the question up to 4, this will be enough. If it is up to 5, then I have to move one more iteration. So I would say the solution for this one is given by x3. By x3, which is equal to 1.89550. So this is the idea of finding, you can say, the nearest approximation for the starting value. Nearest 0 for the starting point. Start from different value will give me different root.